Hey, this is video 2.7, Flowchart and Paragraph Proofs. When we get together next week, we're going to look at these in more detail. We're going to do a lab on how to do proofs, but I just want to introduce these last two concepts, a flowchart proof and a paragraph proof. We've been looking at two-column proofs now, and I just want to show you a couple different ways to do it. One of the theorems you already completed in your notes is this common segments theorem. And that's to say that if segments share a piece, right here, like B to C, and you know that these other lengths between A and B and C or D are the same, that means A to C is the same as B to D. And again, any theorem is something you can prove. So you may be asked to prove this on a future test or quiz or whatnot. So just keep that in the back of mind. Anytime you see a theorem, you should be able to prove it. All right, so first style of proof is a two-column proof. The second kind is called a flowchart. And what this does is it uses boxes and arrows to show the structure of a proof. And sometimes it's easier to follow it that way. And the justification for each step is written below the box. So here, you know, a similar thing says, use the given flowchart proof to write a two-column proof. Okay. Given angles 2 and 3 are complementary, angle 1 is congruent to 3. So let's just label this right now. Let's just put this on here, and I'll use bright colors. Angle 1 and 3 are congruent, and angles 2 and 3 are complementary, which means these two angles here add up to 90, right? So those are complementary. It says use the given flowchart proof to write a two-column proof. Okay, well the first thing it starts with is either one of these two givens. Angles 2 and angle 3 are complementary, and that's given. So generally how you read this is from left to right. We're going to start with this train of thought, work our way down, bring these thoughts together, these statements together, and then finally end up with a conclusion. So this is how it looks. Angles 2 and 3 are complementary. Given. All right, so two-column proof. Statements on the left, reasons on the right. Angles 2 and 3 are complementary. That's a given. And if you want to say right now angles 1 and 3 are congruent, that is also given. So the next step here, the way I'm reading this going down, is what does complementary mean? Well, it means the measure of angle 2 plus the measure of angle 3 equals 90. And the reason for that is that's the definition of complementary angles. And so that's what you write here. Measure of 2 plus 3 equals 90, and that's the definition of complementary angles. Now, I've concluded to this step. I'm trying to merge into this step here. What I need to do is tie these thoughts together so I can bring them together in one step. And how that looks is the measure of angle 1 is equal to the measure of angle 3. You can see we're right here at this point. Well, the reason for that is that's what congruent angles are. Right? By definition, that's what congruent angles are. If they're congruent, then they have the same measure. So now I've got these angles. I'm going to be able to do some substitution here. So I'm substituting angle 1 for angle 3 right here. So now I've got the measure of angle 1 plus the measure of angle 2 equals 90, just as stated right up here. And finally, if I know that, that means that angle 1 and angle 2 are complementary, and that's because of the definition, right? If they add up to 90, they're complementary. So here's another one, another example, and what you're going to try to do here is you're going to try to prove these congruent segment theorem that we looked at earlier, or common segments, excuse me, the common segment theorem. So good, pause the video, try this out. Given this picture, can you make a two-column proof? All right, here you go. Of course, you've got your statements on the left, your reasons on the right, and you walk through it step by step, starting with your given, and then the addition property of equality, right? What we're doing is we're adding ST and TU to both sides, right? And they're equivalent, so if I add 3 to one side and 3 to the other, that's addition property of equality. They're the same thing, right? And again, what you're seeing is RS, ST, TU, UV, these are not segments. It's the length of a segment, right? When you just see the letters without any arrow or line or segment above it, then you're talking about the length. So the length of RS is equal to UV. The length of ST is equal to TU. If I add what I add to one side, I can also add to the other. All right, so I move down a little bit more here. I've got segment addition postulate, right? The parts equal the total. And again, the parts, TU and UV, equal the total, TV. Right, now I'm substituting. Hey, now what I'm saying is, wait a minute. RT is TV, right? I've already established that these are congruent. Now I can substitute for them. And lo and behold, if their lengths are equal, then the segments are congruent. And that's by the definition of congruent segments. Couple more examples here. Use the given two-column proof to write a flowchart proof. Again, they give you the statements and reasons. All right, we have a special guest here. Bjorn has just walked in, and he's going to walk through this two-column proof, and he's going to help me make a flowchart proof. And so this is what it looks like. You follow along, Bjorn, and what's the next reason here? B is the midpoint of AC. You say given. Given, right? And that's what it says in your two-column proof. But now on a flowchart proof, you put your statement here and your reason here. So the next step as we go down, it says segment AB is congruent to BC. And why is that, Bjorn?
Definition of MDP.
Midpoint, right?
Oh.
That's the definition of a midpoint. So a midpoint makes two congruent segments, right? And of course, if the segments are congruent, they have the same measures. That's by definition what congruent segments are. And now you've reached this whole point. Now, when you bring in another train of thought, that's why we've got the second sort of piece coming in here. Because the fact that we've got congruent segments really doesn't have anything to do with the segment addition postulate, but they come together here in step number 5, when you said, oh, one side, AB, the length of AB, plus the other part, AB equals AC, right? And that's from substitution. And finally, you're just going to simplify that, and you've shown that 2AB equals AC. Thanks, Bjorn. The last thing we need to talk about is a paragraph proof. And really, these are the ones that you'll see throughout your life in one form or the next. And the reason is you'll see them not just in mathematics, but anytime somebody is arguing a point, whether that is in a relationship, whether it's law, whether it's in politics, whether it's a family decision, scientific papers, you're arguing a point, and essentially you're trying to prove your point. So a paragraph proof, as you have from your vocab, is just written out as a paragraph. So here's a couple of additional theorems. Vertical angles, and if two congruent angles are supplementary, then each angle is a right angle. Of course, these will come back. You already have them in your theorems. But just take a look at this paragraph proof. Use the two-column proof to write a paragraph proof. So given angles 1 and angle 2 are complementary, prove that angle 3 and angle 4 are complementary. So 1 and 2 are complementary. That means 3 and 4 are complementary. Okay, they've given you the statements and the reasons. I'm going to read through the paragraph to see if it makes sense to you. Now, they didn't start with the word given, but I would start with the word given. Given that angle 1 and angle 2 are complementary, that means that the measure of angle 1 plus the measure of angle 2 equals 90 degrees by the definition of complementary angles. Angle 1 is congruent to 3, and angle 2 is congruent to 4 by the vertical angles theorem. So, the measure of angle 1 equals the measure of angle 3, and the measure of angle 2 equals the measure of angle 4 by the definition of congruent angles. Through substitution, the measure of 3 plus the measure of 4 equals 90. So therefore, angles 3 and 4 are complementary by the definition of complementary angles. That, to me, reads a lot better than a two-column proof. However, I like how the two-column proof keeps everything nice and organized. So here's your assignment. You've taken some notes, you've looked at some examples. what I want you to do is make a flowchart proof from this 2-column proof. Again, given angle 1 is congruent to 4, prove angle 3 is congruent to 2. So I want you to, 1, make a flowchart proof based on this 2-column proof. All the steps are there. It's now can you put it in a flowchart form and then write it out in a paragraph form. Again, as I said, next week we're going to be looking at how to do proofs, how to set them up. You definitely want to have your vocabulary sheets and all your theorems handy, because these are the things that you will be using to support or justify or the reasons for the statements that you make. And hope that gives you a little bit better understanding of proofs.